Welcome to the Tech Ed Podcast, where we visit with leaders who are shaping, innovating, and disrupting technical education. People who are not afraid to think differently, not afraid to try something new, all with the goal of securing the American dream for the next generation of STEM and workforce talent. Welcome into the Tech Ed Podcast. This is your host, Matt Kirkner. Our listeners know that we love innovation. We love high tech. We love education, and we love new products. Today, we are talking about all of that on the Tech Ed Podcast with an incredibly fascinating individual. I am actually recording on location in Fort Worth, Texas, with the president of Creaform, a company we are going to learn all about in our time today. If you're not familiar, I already am incredibly familiar with this company. They're doing amazing things in the 3D scanning space, and it's my absolute pleasure to welcome to the Tech Ed Podcast the president of Creaform, Fanny Truchon. Fanny, thank you so much for being with us.
Hello, Matt. Thank you very much. It is my pleasure.
Awesome. We're going to have such a great conversation. And I want to start out with this. I mean, I know 3D scanning pretty well. A number of our customers probably do too. But just out of curiosity for our customers who may not be completely familiar with the amazing technology that Creaform offers, what can you tell us about it?
So this explanation of 3D scanner is really transferring a physical object into a digital one. That's essentially what all 3D scanner does. Now, if we think about how do we do that? Well, really, for all 3D scanner, you're going to send a form of light. So a form of light on the object. The light could be laser, it could be white light, could be different things. For us, we tend to use for most of our equipment laser crosses, which as it's projected onto a surface, the camera will detect its deformation and be able to recreate the surface digitally. So this will be a surface reconstruction. And this is how you'll get a digital object. And that digital object, depending on the type of scanners, is going to be within a few micron range of the object itself. So for people that don't know microns all that well, it's going to be somewhere between a half to a tenth of a hair of a human hair. So It's pretty precise for something you're doing without touching, and quite fast, I might add.
So I want to put that into perspective for our listeners. You're literally taking light, a laser, you're scanning the surface of a part, as you suggest, creating a 3D, basically digital replica of that part that we can do all kinds of things with. And I know we're going to talk about that. And you're able to scan within 1/10 of the diameter of a human hair. That is absolutely incredible. Have to be all kinds of applications, both inside and outside of industry. Let's start out on the engineering and industrial side. Fanny, tell us a little bit about what the applications for this technology are. Give us some examples.
There are a lot, but I'll talk quickly about four because they cover, I would say, 90% of what the different applications are there. So the first one will be what started 3D scanning, really, which was reverse engineering. So reverse engineering is utilized for product development and other portions of development. It's essentially creating a CAD model of a physical object. So physical object, you don't know the CAD model. What I described earlier, making a digital copy of an object. Of course, it's utilized a lot now for first article inspection, either through a supply relationship or articles that you're creating yourself, and some troubleshooting. The next one, which is the biggest sector of utilization of our equipment, is product quality inspection during production. And finally, a big sector that's been evolving quite quickly is surface damage assessment. So pipeline inspection, pressure vessels, so looking for material loss that you got from rusts or dents or damages. So those are four big sectors that we do in the industrial world.
I just think about all my time in manufacturing, and I spent over a quarter century, running and leading manufacturing companies. And back in the day, kind of the pre-Industry 4.0 day, and I know we're going to get into that in just a minute. If we wanted to inspect a part, we would take samples from the production line, and we would take it into a department we called inspection, where we would have inspectors that would use, whether it was, a radio spectrometry or using an eddy current tester or dimensionally testing a part with a dial caliper or a micrometer. And now what we're saying is we can literally use 3D scanning on the quality side to be able to understand, conformance, not just post-production inspection, but in production inspection. That is absolutely fascinating to me. The reverse engineering part of it, I get it. I mean, we have a part, we want to replicate that part. The application I always think about is a production line goes down and the replacement part is 6 months away or something. And now we have the technology to be able to scan that part. And then I think about, like pressure testing or having to submerge a product in water or something, testing for leaks and so on. And it sounds like we're able to use 3D scanning for that application as well. It really is amazing how far we've come in the world of manufacturing and technology, isn't it?
Yeah, absolutely. And of course, as speed, ease of use, pricing, and I think that's one of the subjects you're going to want us to talk about. It definitely enables a lot of different applications.
Absolutely. Before we get to that, and we love Moore's Law. We love talking about products doubling in price performance every 12 to 18 months, and we'll get into that in a minute. But I really want to talk about something that's been the product of that, which is Industry 4.0 and this whole idea of whether it's smart sensors, smart devices, digitization, digital twins. We get into this whole world of artificial intelligence and machine learning. I want to explore that with you today as well. But before we do that, to help us understand how 3D scanning kind of fits into the Industry 4.0 mold in this new era of manufacturing that we're in.
It's, I think, the perfect example of an Industry 4.0 evolution. So if you think, the example you were talking about from your experience is a good one, but as you're inspecting equipment or parts, instead of having a limited amount of measurement, because taking measurement is in a traditional way is long, it's cumbersome. So you have to choose your points of data very smartly. So now, when you're transitioning to a 3D scanner, you're able to take a full surface, complete surface, and get a precise digital object. So suddenly you go from having maybe 10, 12, maybe 50, maybe 100 data points, if you're being very thorough, to having millions and millions of data points. And this can allow you to analyze parts that you thought might be a problem because you didn't measure it, and you didn't measure it historically, so you hadn't looked. It allows you to analyze free forms, which were very difficult to do in the past. So, and this can be used for so many things. Of course, you can do numerical simulations, statistics, and analysis for sure. You can exchange data, a lot of data between suppliers and an OEM, service provider and operator. Of course, the designers or engineer can look at all that data as well. Really, the possibilities are endless. But now you have data of every part you choose to scan completely, and this can be available and analyzed so many different ways.
We talk often on the Tech Ed podcast about how we'll create as much data in the next couple of years than we have in the last 30 years combined. And this is just a perfect example of that. When you think about, again, going back to my days of manufacturing, and if I had a part that I was tolerance testing or I was testing for conformance, and I might take 4 or 5 readings over the surface of that part, and now we're talking about millions upon millions. And then you think about now we create this huge data set, and we've got kind of every aspect of dimensional measurement as just one example on the surface of that part. Then you start to think about the applications of that for things like lot control, root cause analysis, product improvement, identifying constraints in manufacturing, improving throughput. I mean, it's really the opportunities for this technology are absolutely endless, which is one of the many reasons that I'm so very fascinated by it. So let's take that example one step further. So now rather than having 5 or 10 data points, I've got millions. Now I've got this huge data set that I need to analyze. I'm probably not taking an industrial engineer and putting him in a room with all this data and saying, here, figure this out. I've got to find other ways to find patterns in that data and use it. So tell me a little bit about how the advent of artificial intelligence and machine learning in this day and age kind of converges with the whole idea of 3D scanning and all this data that you're building.
So before I talk about AI, of course, to be able to get real information about those millions of points, you, of course, need the application software to be able to help people and help the workflow to get data, the type of answers you're looking to get out of that data. And the application software works in conjunction with, of course, the software that's powering our equipment. Now, all of these software platforms are greatly enhanced by AI. Of course, it's starting. It's a new thing within 3D scanning to utilize AI power to be able to help better doing image detection. I mean, image analysis and image detection is one of the strong forts of artificial intelligence. So We have started to integrate that within our platform software to be able to better detect the target positioning, enabling us to allow for less targets, have more precise results. We're also utilizing it to do entity detection to be able to better operate. And there's much more to come in the future that I can't tell you about today. I'm sorry about that, but we're definitely something we're putting a lot of efforts into, and we will see over the few years coming a lot of evolution. I sure hope we will be evolving faster than our competitors as well.
Well, if I know anything about Creaform, there's no doubt that you will be, and certainly will be on hand as soon as those big announcements are made to help spread the word, which we're going to do a little bit with some new products in just a moment. Just a quick follow up on that last question. So I understand the targets, and for our listeners, when you're doing 3D scanning of many parts, you're actually placing what we call targets on the surface of that part, and it's a circle or a small disc. Almost think about those little things we used to put around the hole in the on a piece of paper with a 3-ring binder. I'm probably dating myself a little bit, but about that size, that circle, maybe a little smaller than a dime. And we're setting those on the surface of the part. And so now we can use artificial intelligence and machine learning to help detect those targets, to understand target placement, to maybe reduce the number of them, which improves efficiency. And then you mentioned entity detection. I want to understand a little bit more what you mean by entity detection. What is that exactly?
As you're analyzing and trying to measure a part, you come across things like holes or an edge, and being able to know within your software what those are and where they're positioned, and enable a specific analysis of these specific entity, allow you to get better precision, certainly better repeatability on measuring those specific entities. So that's something that we're incorporating as well within our software.
Awesome. And all of this being done, at least in part, with AI and ML, artificial intelligence and machine learning. And it sounds like there's some cool things in development that maybe we'll talk about in the future. But I do know you have some new product news for us here on the Tech Ed podcast as we're recording this, about to make a huge announcement about some new products. So tell us a little bit about what's on the horizon for new technology for Creaform.
Well, I'm going to talk to you about the very short term to start.
Yep.
We're pretty excited. That's actually why we're here in Fort Worth, Texas, is announcing to our America's sales force a new scanner that's going to be hitting the market, and launching a scanner that's called the HandyScan 3D Max.
Okay.
So it's a scanner that emerges from our HandyScan family, but is targeting large parts. Okay. So today in the market, what we see is we are well equipped to do parts of probably something between 0.5 to 3 meters. There's us, there's other competitors. And then there's a lot of things that are addressing very large parts like lasers, like terrestrial scanners, etc. But for parts that are of the size 2 to 8, 2 to 10 meters. There's not a lot of things addressing that market today. And we're coming out with a very versatile handheld, excellent in precision, extremely fast because it's a low target, with a flex volume where you can do either get a lot of resolution by bringing it a bit closer or keeping it further. And that's what we're going to be launching tomorrow, essentially for the Americas, so presenting it to the workforce. You're going to see it's an exciting scanner. It works very smooth, beautifully. It's a simple utilization, and it renders actually very exceptional results. So we've done some beta testing with a customer in Europe, and this came out saying, okay, we're working to find the funding for 3 to start. It was their answer, so they're very excited about the speed, the amount of details that they're able to get. Simplifies a lot more than they used to do those types of measurement with different equipment, and utilizing that scanner was definitely a great help for them.
So I'm just trying to put this into perspective. So when you say 10 meters, I mean, that could be like the size of a like a train car, maybe a small cargo truck. I mean, that's how big we're talking about.
Absolutely.
And we're able to scan that with a handheld scanner and hold tremendous tolerances with a handheld scanner. I mean, that's revolutionary.
It is. It's definitely completely new in the market. It's not coming out with the same accuracy as a handy scan that has a very small field of view, but it's coming out with pretty strong accuracy. So the single point accuracy is 75 micron. So you have to think that you're going to be able to target that on a part that size. So it's definitely much better than the type of accuracy that they're used to, the measurement methods that they do today. So we're excited. And of course, one of the software platform that we have is called VX Integrity. So VX Integrity actually helps a different sector of the NDT. So and of course, combining the Handy Scan Max with VX Integrity is going to be really great for a lot of sectors, like you were saying, car rails or pressure vessels, tanks, a lot of large things that before, because you had to place a lot of the positioning target that you described so well. Well, it took a lot of time to get those inspections done, although they were great inspection. Now we're able to do that 75, 80% faster in terms of those inspections. So pretty excited.
Absolutely. Well, and I just think about, again, all the applications in manufacturing and industry, and sometimes people don't have an appreciation for a 70 to 80% improvement in the time that it takes to do something is absolutely huge. And that translates into better margins in manufacturing. It translates into abilities to reinvest in a business. So if I'm a manufacturer that can drive that kind of cost out of my process, now I'm improving margin. Now I can reinvest. I can compete on price with a competitor if I have to, because I've got that capability to do that. So, it's not just the technology, which is absolutely fascinating. And I can't wait to see how you're doing this. It's going to be awesome to check out this product once it's launched. But just the impact that can have on an industrial employer in the manufacturing environment. I mean, you're just helping your customers find more and more ways to drive margin back into their business, which is really, really cool. And it's fascinating to see how quickly this technology is changing. I mean, I've been on the Creaform radar and vice versa for probably about 3 years, and watching your technology evolve and watching technology in general evolve for several generations. I mean, you think back, we were talking about artificial intelligence. I heard somebody say this morning that, 5 years ago, we were just trying to figure out how to generate language using AI. And now we've got ChatGPT that has the ability to have entire conversations with human beings. It's amazing how fast this is going. We call that Moore's Law after Gordon Moore, who was the famous engineer and innovator and entrepreneur who passed away within the last year, by the way. But this whole idea that products double in price performance every 12 to 18 months, meaning what we can get today for the same amount of money or what we could get 18 months ago for half the price. Literally, technology is advancing at such a rate. So do you see 3D scanning in the same way? Are we really seeing that kind of every 12 to 18 month total innovation and total revolution in the products?
Yes, we do. Absolutely. For a number of reasons. Of course, when you look at the different components that we utilize, because they're following that same law, of course, we benefit from that in being able to have more performing, more resolution camera, for example, or more lasers and just the laptops. So the computers that we use, we are often limited by the processing speed of the computer. So just the fact that computers are pretty much following that law as well is enabling our overall solution. And if you look at what's available in the market, a few years ago, high performance 3D scanners were premium products that larger companies were able to afford. But with all the progress that we talked about now, you can find a scanning solution, not industrial type scanning solution, but for a few $100s. This was unheard of years ago. So it allows individuals to dabble into 3D scanners, often combining with 3D printers, and it allows this to really be available mainstream. So it gets people understanding better what is 3D scanning, because it's still not that well known out there. So today, you want to spend a few $100s, you're going to have a solution that has got a lot of flaws and not a great accuracy and all that. And you want to spend $100,000 because you're an industrial, need with something certified and great repeatability. It's all there. You have a wide range, and that's what we see today. And we see a lot of, in our industry, we see product doing evolution very quickly.
So fascinating. And then you think about, and this is something as you were chatting about this that hadn't occurred to me, but you've got your own rate of innovation at Creaform, and then as things are, vision systems and cameras are advancing in that technology, and anybody who owns an iPhone knows, and has for 10 years knows how camera technology is advancing, certainly at warp speed, and this whole idea of doubling in price performance every 12 to 18 months. Then you have the computer power side of it, to your point, being able to process tremendous amounts of data, analyze tremendous amounts of data. So as those spaces and others are advancing, you're able to morph your company and your model to advance with that technology. So in a lot of ways, you're both leading and maybe in some ways being pushed by other technology companies, and everybody's just kind of racing to keep up with each other, which makes it a really, really exciting time. You must wake up and just love your job every day to be just in the middle of all this technology. Is that right?
You described our reality so well. It's exactly our reality. We're condemned to lead, but we're also enabled by all of our supply chain, and we are pushed by our competitors, and that's good, And we aim to make sure that we find not gizmo or just evolution for evolution to give our customers, but that we truly understand their need and make their life easier and really bring value to their business. So, because just innovating for innovation is fun, but at the end of the day, it doesn't add value.
We talk about that a lot. I was at a big automation conference last week, and I can't tell you how many speakers got up and talked about don't automate a manufacturing process for the sake of automation. I mean, don't buy robots just because you think you have to have robots. Use it to solve a problem. And to your point, your advancements and your innovations should be solving customers' problems, making them more efficient, making their lives better, making them more profitable. And I think technology companies that keep that model at the center. I think back to Steve Jobs and how he was so maniacal about we're not adding anything that doesn't add tremendous value for our customer, and you've got exactly that same mindset, which is, I think, exactly right. As this technology, Fanny, moves forward so fast, and it is just fascinating to watch it, we have a need to prepare that next generation of learners, of students, of the people that are going to be or maybe are using this technology in manufacturing. So talk about that a little bit. As we think about getting 3D scanning into more companies and into more schools. How do you think that's going to affect the rate of innovation in the world as we have both companies, industrial employers, and we have schools innovating in the area of 3D scanning right along with your products? Tell us about that.
Well, definitely when 3D scanning first made its appearance, it had a huge impact on development cycle, the methodology that people use for development, because really being able to create a digital twin of an object really affects a lot of the different portion of the cycle. So, and it's going to continue. It's going to continue because as the equipment becomes more available to a lot of people, so it's going to impact, of course, the speed, the accuracy, the type of complexity of surfaces. Of course, we deal with surfaces. So I'm going to talk about that, but the type of complexity of surfaces you can do not only in form but in finish as well. It definitely helps reduce the number of iteration that you do, because now you have a digital version of something. You can do some simulation on it. You can do some validation as you have that digital model. You can change it into your CAD environment, etc. So it's definitely something that I think in the near future, you're going to see very little product development that's going to be done without having a 3D scanning portion in it.
That's fascinating. I mean, and it really speaks to what a great spot you're in the overall economy. If you're getting into this point where when you think about all the innovation, all the engineering that takes place, if we're really getting to a point where almost none of that happens without some element of 3D scanning, that certainly bodes well for the future of your company and for the future of technology as well. We've talked a lot, Fanny, about applications in industry, or we talk about pressure vessels, or we talk about rail cars and so on, dimensional tolerances in a manufactured part. There's some other interesting applications for 3D scanning that we really haven't gotten into yet. Give us some examples of outside of kind of the traditional manufacturing and industrial markets where you see 3D scanning adding value.
Yeah, absolutely. So some of the places that were present and that are starting to take some speed, forensic is one of them. We had our moment of fame with being a part of shows like CSI. So we see a lot of museum or preservation groups utilizing for heritage and preservation. So as you have a monument, a statue, a sculpture, even a painting, at times people want to be able able to keep a digital bank of those. So they create 3D scans so they can create a precise digital model of this. So should something happen to an object, should you have to restore it, fix it, then you have that. Of course, animation and video game programming use a lot of 3D scanning, and more. The construction sector is really starting to get really big into 3D scanning. So not only the terrestrial scanner, which is what we used to see them at, but they're starting to use more and more handheld scanner to be able to preserve or position things more precisely at a smaller level. Of course, body scanning is utilized for a lot of different things, whether it's medical, whether it's, we talked about gaming or so a lot of different things, car body damage assessments and upgrades. So a lot of different people that are doing car body work or bike body or boat body that are doing basically body upgrades or body repairs are utilizing 3D scanner. And I mean, I could go on. And
it's almost every space within the economy, right? And a lot of those are, I suppose, if I thought about it for a little bit longer, maybe would have thought about some of those on my own. The whole aspect of preserving an art collection, I mean, that I think is really cool. I actually live not too far from an art center in southeast Wisconsin, and in north of us by about an hour, there's a huge art preserve, which I actually got a behind the scenes tour of not too long ago. And just seeing, in the background how they really are. They're using 3D scanning to, one of the applications I saw that was really cool was they were scanning bits and pieces of a sculpture that had disintegrated, is the wrong word, but it had broken into several pieces, and they were trying to figure out how to put this thing back together. And they were literally using 3D scanning technology to scan the component pieces so that somebody could figure out how to restructure it. So all of these applications, all of these different market spaces, now we have to figure out how do we prepare the next generation of students, of engineers, of artists, of whether it's somebody working in a car body shop that's doing some of this work. I mean, all of these individuals are going to have access to this technology. They're only going to be as good as their ability to use it and understand its applications, which really speaks to getting it infiltrated into the education space, whether it's here in the U.S., middle schools, high schools, technical colleges, universities, and so on. So who should be learning this technology? Talk to us on that topic.
I think anybody that's close to the manufacturing or the industrial world, engineers, any of the tech school related to engineers, that's a must. But I think that's pretty much present nowadays. Anyways, I'm hoping I think it's a lot. But when we think about anybody in the medical field, dentistry, anybody in architecture, I think they need to be introduced to that, having a great level of detail, because then it depends on what they're going to be utilizing. Construction, of course, industrial design, etc. But me, I'd like to think that everybody that comes out of high school has had a chance to play with a 3D scanner. They understand the principle of it. They know how it fits with a 3D printer, and they know that this is something that exists in the world, and so that we can have people in the future think of completely no application and help drive, that productivity that we're going to be we're looking for so much within the coming years.
Well, and as educators look to find more and more real life experiences for students to learn. We can put them in a classroom, we can give them a textbook, we can talk about 3D scanning, or you can have a student that goes into their tech ed program, their pre-engineering program, even their art program. They're putting their hands on the technology. I mean, what better way to learn, whether it's 3D modeling, whether it's a CAD system, engineering, reverse engineering, to be able to grab a 3D scanner, scan a part, turn that into a digital replica of that part, and then manipulate it in any way that they want. I can't think of any reason, quite honestly, that every school, regardless of level, shouldn't give students access to this technology. So it's going to be exciting to watch this roll forward as we inspire this next generation of young people toward really, really amazing careers. And I would be interested to listen to your thoughts, Fanny, on if I'm somebody just starting my post-secondary journey. So I'm in like high school, or as we call it here in the U.S., my K-12 journey, and I'm an 18-year-old individual that's 19 years old, and I'm thinking about what comes next. What advice would you have with regards to career planning and thinking about the future, and especially for young girls of all ages who might have and aspire to an amazing technology career in a leadership position like the one that you have?
It's a good and difficult question. So, of course, we all know that the world is going to become more and more technological. There's no escaping it. It's already, it's already been happening for a long time. So for me, there is no doubt that having a strong technology-oriented education background brings a lot of value and a lot of credibility to an individual on the market. So I guess what I want to tell people is incorporating a technology portion in the education, or going really a more technology route completely, to me adds a lot of value, and does not mean that you're going to be doing necessarily very technical work all the time. And this is something I try to make sure that people incorporate in their reflection, because people are thinking, I'm not sure I want to be an engineer because I'm not sure I want to do technical work all the time. Well, I'll take a really simple example in my company. In my company, my marketing vice president's an engineer. All my product manager are engineer. All of my salespeople are engineers. I have technical writers that are engineer. I have a finance person that's an engineer. Wow. The reality is, because we're a technology company, having this knowledge and maybe pairing it to something that in the end you discovered that made you feel more happy or you were more comfortable with, really brings a lot of value. And I'm going to say, and today, and maybe it's wrong or it's right, but it's still true that today, even for young women, having a technology background or having a portion of technology within their education background brings a lot of credibility, and I think brings a lot of confidence as they are going to a workplace that might be more closer related to technology. To me, I think that's something to consider. It doesn't mean it's for everybody, but I think it's for a lot more people that today I might not be incorporating that into their reflection about their career.
Absolutely. And it just opens up so many options. That's one of the things we tell folks, is that, there's certain pathways and certain degrees that, if you go into engineering, you're probably not going to be sitting at a desk doing trig and calculus for the rest of your life. There are some who do, and if that's your thing, awesome. But there's just so many different avenues within technology that students can explore, but they'll never have that opportunity unless they're at least making a decision to follow a STEM or a technical pathway, or at least making a decision not to not follow one. In other words, you don't necessarily have to be on that path, but sample some of the STEM courses and take a fascination in science or technical education or pre-engineering, get a sense for what that's all about. You never know, you might end up being the president someday of this amazing technology company as you have. And so you should be obviously very proud of your career and where you're taking your company. We want to wrap up our time with Fanny Truchon today, president of Creaform. With a question we love asking our guests here on the Tech Ed podcast. I want to go back in time. So you're 15 years old. At that time, you were living in Quebec City, Quebec, Canada, loving life, your whole life ahead of you. And if you could go back in time to give a little piece of advice to that 15-year-old girl, what would that be?
Well, I think for me, the advice I'd give myself it would be try more things. And I don't think I didn't try, I think I tried a lot. I'm extremely happy with where I'm at career-wise, and not just because I have a great position within my company. I mean, for me, engineering and manufacturing, it's the thing I love. And I really got there by chance. It was kind of a that I ended up, and I'm thinking, wow, I'm a lucky person, and I could have went a different way. So, I mean, for me, I would say try different things, pay attention, ask people question what they like, what they don't, what do you like, what don't you like? So try music, try theater, try working at the mall, try working in a restaurant, travel, figure out what you love, because that's a thing you're going to want to make sure you incorporate that in your career path. It doesn't mean you're going to be an actor because you're doing theater. It means it's something you like, and there's a portion of that can be incorporated in your work. So that's what I would tell my 15 years old, do stuff, pay attention, ask questions, and figure out what it is you like, what it is you like less, what are you good at, what do you really want to do? It doesn't mean as a career, right? That's difficult answer, saying what do I want to do as a career, but figuring out what do I like as a person is a much easier way to think about the future. And that's something nobody ever told me. People said, oh, good grades, you can be a doctor, an engineer, or this. It's like, oh, okay, which box do I choose? Fit in any box? Nobody does.
I love that advice. I wrote a magazine column, I think it was within the last 6 months, about aligning people with the things they love to do in a company, and so just as a generalization, people tend to excel at the things they like to do. Nobody gets really, really good at something they don't like, because at least very few people do, because the truth of the matter is you're not going to have that energy and you're not going to have that interest around something you don't enjoy doing. But if you can spend time doing the things you like, those are the things that you're going to tend to excel at. And so taking an individual, a business, whatever the individual is in a company, and putting them on a path or putting them in a lane that's consistent with what they love doing, it's amazing the result. And really, I kind of think about rolling that back to a 15-year-old girl and saying, you got to try a lot of things to figure out what it is that you like. And I love the way that you characterized. I don't know that anybody's ever put it quite like that to me before. Don't worry about what your whole career is going to be. Figure out what it is that you love to do, what you really enjoy doing, and then explore opportunities that maybe allow you to leverage whatever that interest is. You've certainly, Fanny, done that through your whole career. You're a fascinating individual, fascinating background, an incredible company, working with just unbelievable technology. So can't thank you enough for you to, here in Fort Worth, Texas, spend a little time with us here on the Tech Ed Podcast, talking about trying new things, one of which is spending time together, having this amazing conversation. And Fanny Truchon, president of Creaform, thank you so much for being here.
Thank you very much. This was a very interesting conversation.
Thanks for joining us for this episode of the Tech Ed Podcast. If you haven't already, subscribe, leave a review, and if you like this episode, share it with a friend. New episodes launch every Tuesday, so listen in next week.